today we're going to continue what we were doing yesterday, solving triangles. But we're going to do it all the way today. Um, that I mean, we will be finding a single angle in the triangle and every single side, and that's what we considered solving the triangle. Okay, I posted the note sheet or not, but these are the notes, and those in class will at least have a note sheet. When we solve for a triangle, all we're saying is find all the angle measures, side measures of the triangle. We're only doing right triangles, so when you solve it, you will have answers for all 6 of these measurements. Now, to go about doing this, we want to develop a strategy. And so this is broken down into 2 types, basically. Hey, what if I have to find a side? And then what if I have to find an angle? So if you know 2 of the side lengths, then one way to attack it, a good way to attack it would be to use the Pythagorean theorem. That was something we learned early on in this chapter, but for right triangles, a squared plus b squared equals c squared. And remember, c is your hypotenuse. The other 2 are just either of your legs. Okay, then when you get done, you want to simplify your answer. Then a second method you could use, if you know just one side and the measure of one angle, then you could use your trig functions. Okay, so we'd write, for example, sine of the angle you would know at that point, whatever that angle is they give you, equals your ratio, opposite over hypotenuse. And because you know the angle and they give you one of the sides, you would be able to calculate another side. So let's take a look at each of these things. First, if you know 2 side lengths. So here we go. Got a right triangle. I know 2 side lengths, so I can use the Pythagorean theorem. A squared plus b squared equals c squared. And so 171 squared plus b squared equals c squared by 500. So we get out our calculator at this point. When I square the 171, I get 29,241 plus b squared equals, then you got to square your 500, which is going to give you 250,000. Now I'm going to subtract away this 29,241 from both sides, giving me b squared equals, let's do that subtraction on my calculator, 2941. So like b squared is 220,759. And then I'm going to square root that. So I hit my square root button, and that was not my square root button. This is. I get 469.8, so I'm going to call it about 470 units long. So that's using method 1 here, and it's kind of highlighted in red for you. So let's continue. That's how long this side was here. So now I would know, for example, hey, this had to have been a 20-degree angle because it has the same value, same sine value, 171. Second method here. If you know one side and an angle, so here I know my angle is 500. It says to find AC. So I know one side, 500, and I know the measure of an acute angle. Remember how we do this? We're going to settle on the angle we know. I'm trying to find the opposite side. And so I'm going to use sine of 20. It's going to be opposite over hypotenuse. So sine of 20 equals the opposite, which I don't know. That's my AC, over the hypotenuse, which is 500. So multiplying 1 times AC, and then I have to take 500 times the sine of 20. So again, I'm going to pull out my calculator here. Try it on your own if you'd like to. So 20, and I'll take the sine of that. And then I'm going to multiply that times 500. And I get 171.0, so AC is 171 units long. And all right, our next strategy is finding angles. And again, we can break this down into two types. Um, the first type is we just know one of the acute angles, and we're supposed to find the other angle. Well, then we can just use the angle sum theorem. Remember, the angle sum theorem says that everything has to add up to, in a triangle, the three angles add up to 180 degrees. Now, since all of these are right triangles, we've already taken away 90 of it. So these two, angle A and angle B down here, they have to add up to the rest of the 90. So if I just subtract 20 from 90, I just found that other angle. So this would be the quickest way if you're fortunate enough to be given two angles, or because you got the right angle. That's that example. Here's the other method, and this method is if you don't have any angles, but instead they give you two of the sides. And that's what we worked on just the other day, where we could use our inverse trig functions to find angles. So we get the ratio by looking at the sides, inverse sine it to get the angle. So in this case, I'm looking for angle B, and that's down here. So right away now I can define my sides. There's the opposite. Hypotenuse is the long side, and there's our adjacent. And I look at it from my angles point of view. I know the opposite. I know the hypotenuse. That's the sine function. So the sine of angle B equals opposite over hypotenuse. So sine of angle B equals 171 over 500. We'll inverse sine it to get the B, the measure of the angle. So I'm going to get out my calculator and I'm going to type in 171 divided by 500. Gives me 0.342. Now I'm going to hit inverse sine to undo that ratio. And it tells me that angle B, measure angle B, is 19.998 or 20 degrees, just like we thought. That had to be a 20-degree angle right there. We'll look at a few examples here to see how it is done. And so here's a triangle. The directions are just solve the triangle. So the first thing you want to do, let's make a list of everything we got to find. So we got to find the measure of our angles. And then we've got to find the sides, x, z. Oops, don't have the line over it, because we're talking about the length of it, its measurement, not its name. xz, zy, and xy. I think I got them all. So 6 things we have to know. And let's start filling in things we do know. We know angle z is 29 degrees. That was given to us. We know xy here is 18. You can attack it with either trying to find the angles first or trying to find the sides first. Since they gave me an angle, I'm going to quickly find my other angles. Since the two angles z and y have to add up to 90, I just need to subtract that 29 from 90. Okay, that's 61. So angle x here, I should have filled that in already. That's 90 degrees, and angle y must be 61 degrees. Now we're off to find the sides. Now for sides, if they'd given me 2 of the sides, I could use the Pythagorean theorem, but they did not. And so my only option here is to use trig. And so I can work from either of the angles. Now the angle I would choose to work from is the 29. And the reason I would do that is because that is a given angle. It wasn't calculated like my 61. So if I'd made a mistake, I don't want to exacerbate it and make it worse. So there's my opposite side. Here is my hypotenuse, and this is my adjacent side to angle z up there. And so now I just got to figure out which trig function I'm going to use. I want one that uses the opposite, and let's find hypotenuse. So opposite and hypotenuse, that's so. So I'm going to write sine of 29 equals opposite over hypotenuse. So the sine of 29 is equal to, my opposite side is 18, and my hypotenuse, we'll just call it h. I'll cross multiply here. H sine 29, again, that h goes on the outside. 1 times 18 is 18. And so h is dividing by sine 29. Side h is whatever 18 divided by the sine of 29 is. I'm going to grab my calculator. 18 divided by 29, we'll take the sine of that. I'm getting a height, or a hypotenuse rather, of 37.1. So now we know what this is. 37.1, that's zy. At this point, if you wanted to, you could use the Pythagorean theorem. I'm just going to continue on with trig since that's what we've been working a lot with. So let's go ahead and for the adjacent side here now, I want the adjacent side, that's side xz, the one I don't know yet. So I have opposite that I know, adjacent I don't know, opposite and adjacent, that is the tangent function, TOA. So tangent of angle z, or 29 degrees, is opposite over adjacent. So tan 29 is the opposite, 18 over the adjacent, and I'll just call it A. You'll do exactly the same thing that you did, or we did right here. You'll multiply and you'll do some division. You'll find out A is equal to 18 over the tangent of 29. So let's just check that on our calculators here. 18 divided by 29, tangent of that equals 32.5. Same deal, I would list everything you have to find so you don't miss it. Looks like we're missing a letter here, so let's call that side, or angle B. Like so. Then we'll label our sides here, so we got to find side CD, CB, or BC, and BD. Let's fill in what we know. Angle B is 90 degrees. Angle C, we do not know. Angle D, we do not know. CD is 75. CB or BC is 21. We don't know what B, yeah, we do. Got BC listed twice there. We don't know what BD is. So let's go ahead and this time, since we know two sides, we can find this third side. Oh, I guess that's supposed to be the X right there. It's all right. I'm going to go ahead and work it with B. Let's go ahead and use the Pythagorean theorem. A squared, one of the legs, plus the other leg, I don't know that leg, has to equal the hypotenuse squared. We have our calculators. And we go 21 squared, 441, plus B squared equals, and we go 75 squared, 5,625. And so you subtract that 441 from the 5,625, and you get 5,184. And then you just have to square root it. So you hit that square root button, and it comes out to a nice even 72. It's kind of neat. So now we know two of our sides, or all three of our sides. Let's work for angles. Now, angles here, unfortunately, we didn't get any angles, so we're going to have to use that inverse our inverse tangent, sine, or cosine, our inverse functions. So let's go ahead and you can decide which angle you want to find first. I'm just going to go ahead and say I will find side or angle D first. And by deciding angle D, that defines my opposite side. I already know my hypotenuse, but it also defines my adjacent side. So I'm looking for D. I have to use two sides that I know. You could use the 21 and 72, or the 21 and 75, or 75 and 22, any combination. I would use a trig function that uses the sides that were given to you, just in case we made a mistake here. This is the opposite, this is the hypotenuse, so I'm going to use the sine function. Now go sine of angle D is equal to opposite over hypotenuse. So sine of D equals 21 over 75. And therefore D is the inverse sine of 21 over 75. And again, we go to our calculators. This is where it really pays to have a standalone calculator. So I'm doing 21 divided by 75, and my answer for that is 0.28. And I have to hit the inverse sine button, sine to the -1, it looks like. And it tells me 16.2. And we'll call that degrees because that is an angle. 16.2 degrees. And on how you find that third angle, let's mark this one angle D 16.2. I think the easiest way to do it is, since you have the other acute angle now, the two acutes have to add up to 90 degrees. So just subtract that 16.2 from the 90, and you will know the measure of the other angle. So this other angle must be 73.8 degrees. So 73.8 degrees. Doesn't take too long to do these things. See, we got way too many examples on this. I skipped the last example just because this video is getting way too long. So let's list what we have to find. L, measure of angle N, measure of angle M. Supposed to be putting that list down where it says make my list. So we'll do them down here. And then our sides. NL, LM, and MN. And what we know this is 52 degrees, and we know our hypotenuse, LN. Let's mark that as our hypotenuse. LN, that's our first one here, is equal to 3. Well, let's go ahead. Since they give us one of the acutes, let's find the other acute. Just subtract the 52 from it. Gives us what? 38. So now I know 38 degrees right there. And let's mark that one down. Angle N is 38 degrees. I guess I should have done the 90 degrees as well. Since we only know one side, we're going to have to use some trig. I would use the 52 degree angle down here. And let's call this our opposite side right there. And we'll do that with our hypotenuse. Opposite and hypotenuse, and the angle of 52. So sine 52 is opposite over hypotenuse. And I chose those. I chose the sine function because it contains the side I do not know, opposite, and it contained a side, the hypotenuse, that I did know. Now that's not a 0 there. That is the letter O for opposite. And I'm going to change that because that's going to confuse us. I'm going to call that side what its name is, MN. Now this is over 1, so you go 1 times MN, which is just MN, equals 3 times the sine of 52. 52. And so 52, get the sine of him, I take in times 3, and I get 2.4, we'll call it. So Mn is 4 units long. And then lastly, to find Mn, you got your choice. You could use some trig to find that, or we can use the Pythagorean theorem. Notice it's a leg, and here's your other leg. So it's leg squared plus leg squared. So let's go ahead and do that. Lm squared. I don't know why my pen's writing large now. Lm squared plus the other leg, which I now know, the 2.4 right here. 2.4 has to equal the hypotenuse squared. So Lm squared plus, let's see what 2.4 squared is. 5.76. And well, that looks like a 3 to the 9th power there if I ever saw it. But that's 3 squared, or 9. It got squared it as I wrote it down. So we're going to subtract 5.67. That's going to give us, what, 3.34, I think. Let's see, 3.24. I believe that's correct. And then we just have to square root. Double check it though. 9 minus 5.76. 3.24, and then we will square root it. So Lm is 0.8. So I did square root both sides there. So that's our last, it's not Lm we were looking for. Yeah, I labeled these upside down. There we go. 2.4 for Mn and 1.8 for Ln. And that's it. I'll jump you right to what your homework looks like. You 3 triangles, and you have to just solve for them. Good luck.